Okay, let's start from where we left off. So I was talking about WC. So WC is basically what it prints out is first the number of lines, then it prints how many words there are, and then it's going to print the number of characters. Okay, so if your file is something like this, like it says test, then it says like test1, and then it says like test2. So the output is going to be, first is going to be 3, then it's going to be number of words, right? So it's like 1, 2, 3, 4, 5. So it's going to say 5, and then it's going to say how many characters there are. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's going to say 16. So that's how WC works. You can give it a try by yourself. Now probably the best command you have in Linux, which is grep. So what grep does is it finds every single, like it goes through every single file that you have mentioned, and it will find a pattern. Okay, so for example, in your current directory, if I write ls-l, I have these files, and I want to see wherever the word return is. So I write grep -n return and then driver. So what -n does is, well, go to man grep and see what the options do. Sorry, the switches do. Okay. So after running it, we see that in line 47 there is return 1, in line 67 there is return 2, and so on. Okay. So that's what it's going to do. It's just checking the driver.c. You could have used something like a star, and in that case it would actually go through all of the files and find wherever the return word is located. Okay, so you can use it in different ways as well. So for example, you write dot like star.c. So this star actually means wild card. It's actually called wildcard. So what it does is it basically means like every single thing that is available here, it's going to take them in. And by saying like wildcard.c, it basically means every single file that ends with .c is going to be checked. Okay, so I would actually suggest you to go through the wildcard in like Google, like search Linux wildcard, and it will actually explain how things work. I will try to explain it in the lecture video, but the problem is like it's not possible to cover everything in the slides, but I'm trying my best over here. Okay, I will try to give you other examples as well, but that might be some extra videos, and I am not sure whether you're going to be happy to have even more stuff to cover. Okay, so another command you can use is pipe. So what pipe does is it actually well, how it works is over here you write ls, right? We know that ls basically prints the list of the like files and directories that is available in your current directory. Then you use pipe. So what it's going to do is use ls's output as the input for wc. Okay, so in this case ls is printing this whole thing, like this whole part is going to be taken as an input and put inside wc. So wc is going to be like, okay, so I have 10 lines, because ls actually prints them as a line, but for like user experience purpose it's being shown like this. Then it will say that I have 10 words. Over here you have 10 words, and then it will say the number of characters. Okay, so that's how it works. What pipe does is you can actually chain a lot of commands using the pipe, and that's for the expert users. For now you should just be using like 1 or 2 pipes at maximum. like at max. But yeah, I hope it made sense. So what it does is whatever is at the beginning, whatever output it's going to be producing is going to be sent as an input for the next command. Okay, give it a try and see how it works. Okay, so the other one is redirecting output. It's pretty fun one. So we are using this command line command ls, right? So if I write something like ls minus l and then use this, what it's going to do is tell the terminal that I want a file called files.txt, and whatever is going to be printed by this is going to be the content of this file. Okay, so after running this, if I take a look inside the files.txt, this is what it has inside of it. Give it a try, like see how it works, like try pwd and then try to create a file called this. So from this you can also see that this is a like another way of creating files. Okay, and you can use, okay, this was the option for one direction. If you use this, it actually appends the file. Okay, so instead of doing this, if you wrote something like this, it would add this part at the end of the file again. So this one works as a redirection, this one works as a append. You can, again, like I said, give it a try by yourself and see how it works. Okay, so the other redirection option is take something out of a file. For example, if I write wc and then the redirection and the files.txt, it will take this as an input and print whatever is here. Well, this is very redundant in this case because that's how wc works, but try it for other stuff. Like for example, you have a file .txt which has a address, like for example home, your PID, and like, you know, test.txt. And if you write something like wc file.txt, it's actually going to go to this place and print the line number and then like a number of words and characters over there. Another command is file. It actually tells you what the file actually is of. Like for example, if I'm trying to see what the test cases.txt is, it is just an ASCII text. If I take a look at the driver, it says that it's an executable. If I try, for example, file, in this case, like generator .c, it will tell me it's a C source file. Okay, now we are going to take a look at the permissions. Okay, so whenever you wrote something like ls minus l, you saw this whole thing, and maybe you were wondering, what are these? So what they are is called file like permission bits. Okay, so another thing we're going to take a look at like is like who is the owner, who is the group, uh, like what is the group and what is the other. The other basically means world. It means that like everyone. Okay, group means like whichever group they belong to. For example, all of you are part of the group ugrad in the R login, and for example, for me, I am part of the group grad. Okay, so this is like which group you belong to, and owner basically means whoever the user is right now and whether they are owner of that specific file. And the bits work this way. The first bit specifies read permission, the second one is write permission, and the last one is executable permission. Okay, so let's see. So the first thing is file type. If it says that it's hyphen, it basically means that it's a normal file. But if it says D, it means it's a directory. Okay, So the first batch is actually the file permission of the owner. Okay, the second batch actually is the permission of the group, and the third batch is actually the file permission of others. Okay, so number of link, then you will see a number, like very random number. These are links, and I don't think you will be learning about this in this course, so you can ignore it for now. Then it will specify who is the owner of this file. Okay, in this case, it's the owner is McQueen, and then it will say what group this file belongs to. For example, if there is a file with ugrad, like as a group, and it has a read permission on that, then you as a ugrad can access that file. And if it says something like owner, and all of these are like doesn't have any sort of like permission, in that case you can only access it if you have the read access. Okay, yeah, well, this is as far as I can explain. For like there can be so many combinations of it, but you have to try those by yourself. Over here, it specifies the size, like how big the file is. Then it will say when it was modified last. And of course, at the end, the name of the file. Okay. So you can actually change the permission of the files. You use the command chmod. So how it works is, like, for example, in this directory, and this file has the permission of this. It's owner has the permission to read and write. There is no executable permission. The groups have the permission of read and write and no other permission, and the others do not have any sort of permission. So if someone who is not the owner or belongs to this group tries to read it, they cannot. So any commands such as like cat, less, or like head, tail is not going to work unless you are McQueen or you belong to comp.org group. Okay, so if you want to change it, you write chmod space, you say like group minus rw. So you are taking away the group's permission of read write. Then you specify the file name. In that case, if you try to take a look at like what permission they have, you see that the group doesn't have the permission to read or write. So now if someone who belongs to this group tries to access it with any of this, they cannot. Give it a try. And yeah, so there are other ways to do chmod as well. I prefer that rather than this. So you can actually use binary version of it like chmod, and you specify something like 700. So 7 translate to this, 00 translate to this. So it means that RWX. So this is what I prefer. It's up to you how you want to do it. And if you want to know more about it, try to do man chmod and see how it works. Okay. So this is for UX purpose only. Remember, I keep saying they are bits, right? So it basically means if it has a hyphen, it's a 0. If it says R, it means 1. If it's W, it means 1. It's a hyphen, so it's a 0, and so on. So that's how the whole like bits work in this case. So for example, if you use chmod 0, it will have no access permission. If you use 1, it will have the executable permission. If you use 2, it will have write permission. If you use 4, it will have read permission. And if you use something like 5, it's going to have read and executable for permission. It will not have a write permission. Okay, so again, this is something you should be trying by yourself, and because for me it's not possible to show you every single combination, right? But again, if you have any sort of questions about it, you can ask in the PLC. So these are some of the examples that I have already mentioned. And again, try to do them by yourself. You'll be using logical OR to combine them to get your own set of permissions. So yeah. So the reason it is important is because, like, whenever you're working with a server or something like that, for example, in this case, you'll be using our login cluster, right? It is very important that your files have necessary permissions, because if it's available for others, they can just like remove your file or something like that. And if I wasn't like, for example, I also have a our login cluster access, right? And if I don't have the particular permission bits, and if you try to access it, you can actually see the content of it. So you will be able to look into whatever I have put in my cluster. So if I didn't manage my permission bits correctly, you will have access to it and so on. So it's always important to have like the right kind of access bits, right? It's for security purpose. Now we are going to take a look at the command tar, and it's a very infamous command. And whenever you are going to be using tar, make sure you have a backup of that. Like every single file you want to use for the tar, make sure you have a backup of it. I cannot stress enough how important that is, because many times people actually lose their file because they use the tar incorrectly. Okay, again, I am stressing it, and I cannot stress it enough that whenever you are using tar, make sure you have a backup of it, because if you do not have backup of it and if you do it wrong, you will probably lose the file that you are trying to use tar on. Okay, please remember that. Please do not come back to me and say, hey, I mistakenly put the tar comment wrong and I have no idea how to fix it, because it's not like, it doesn't go backwards. It cannot be changed. It cannot be undone. I don't know if you understood that reference. So how it works is, like, tar has a parameter. It uses like CVF. C means create, V means verbose, which means like it will actually show which file it took in, and then it will create a file. Okay, so in this case, tar, I'm telling it to create a file, and I'm telling it the name of the file, and I'm telling it to put this type of files inside of it. So how tar works is, it's kind of like a zip file, okay, but not a zip file. It's just like putting them together. You can actually do like compression as well. It has other commands for it. Try man tar to check how to do that. So yeah, so here is the part about the terror, right? So we are going to try doing a tar by doing this tar cvf. We're specifying the name of the file and so on, and maybe make a file out of it, right? So when we tried that, we see that our tar file was probably created, but this file got corrupted. Okay, instead of being a C file, it's now a tar file. So if you make a mistake like this, you are going to lose your assignment. Don't do that. Like, trust me, don't do that. So here is a meme. It's a very old style of meme. So like, there is a bomb, and it says that the bomb will detonate if you get the tar wrong, right? So you have to put the tar command correctly in less than 10 seconds. You don't have any time for Googling. And he's like, I'm sorry, I cannot do that. Because if you ask me suddenly to do a tar, I'll probably get that wrong as well. And I would use Google to make sure that I'm doing it right. So there are safer ways to do it. You can actually take a look at our like Canvas website, Canvas, and download the safertar.sh and try using that as well. It's a script file that makes sure that you do not end up removing your, you know, removing your source code. It's kind of extra step, and usually like it will save you from destroying the file you were trying to do a tar. So it's up to you whether you want to use it or not. Okay, so inside the tar, if you want to check whatever stuff is inside the tar, you use tvf. Like you use C to create a tar, you use T to see what's inside of it. And if you want to extract it, you use X. Okay, and there is another thing, a tar file that is not a flat. So a flat tar file means it doesn't have any directory inside of it. Okay, so if it has a directory inside of it and you use like tvf, it will say that there is a directory inside. Remember, I told you that whenever it ends with a backslash, it is a directory. You can also take a look over here, it says D, so it's a directory, right? So this one is not a tar file, flat tar file. Okay. So in the assignments, we will sometimes specify that the tar file has to be flat. So make sure you're paying attention over here. Okay. So if we specify that the tar file has to be flat, make sure it's flat. Make sure it doesn't have any sort of directory inside of it. Otherwise, the autograder will fail. Okay. So yeah, if you want to extract a file, you just like specify X. And if you want to specify where it's going to be extracted, you specify -C, like this. Okay. And if you go inside this xtemp, you see that the files are extracted there. Again, give it a try by yourself. There are other compression tools like gzip, bzip2, etc. You can take a look at their man page or run them by yourself. There is obviously the zip, the one you use in Windows or Mac OS or whatever. In that case, they actually run a compressor to, like compress the content of the file. So if it's like 1 giga, it can be turned into like 800 megabyte or something like that. You can do zip by doing, sorry, you can do zip by doing this, like zip the source, sorry, the destination, and then you specify which ones you want to zip. And if you want to unzip it, you specify like unzip -L, and you actually put the name, and it will unzip whatever the file it was. Okay, give it a try by yourself and see how it works. There are other unzip commands, like for example gunzip, bunzip, unzip, which work more or less the same way. They basically use different compression algorithm. So yeah, there are some ways to delete files. There is RM, which doesn't actually delete it. The content is always going to be there unless something else replaces it. It is called de-indexing, and you will probably learn more about it in your OS course if you ever take it. If you want to completely remove that file, you can use shred command and or like dd. Okay. So let's take a look at these special characters, like what do they mean? I have already talked to you about the wildcard. See, this command is called wildcard. So how it works, let's see them one by one. So first we have the question mark. The question mark basically means like it matches any single character, one character, okay? So if you write something like test question mark dot c, then it's going to find for every single file that has something like test, then one character over here. It can be a b c 1 2 3 whatever, and then it ends with dot c. Okay, so question mark basically means one character. The star means wild character. It means 0 or more of that character. Okay, like more characters. It can be 100 characters or one character. It can be any number of it. Then we have the brackets, matches any of the characters within the braces. Okay, uh, like for example, you write something like test 1 2 like 4 for example dot c, then it's going to take a look at every single file that has like test 1 test 2 and so on till 4. If it is test 5, it's not going to show up. Okay, so let's see how it works. For example, dot like wildcard.txt or asterisk.txt is going to find every single file that has the extension txt. Now we can try this. It's going to match every single file that starts with foo, then has one character afterwards, and then it has a dot, and then it might be anything like any sort of extension or whatever. If we write something like this, it's going to find a file called like afu, bofu, sofu, or whatever, and it has to end with an extension HTML. Okay, so this is something you will be using if you are using your R login. SCP is basically like secure copy. Well, what it does is it copies to a remote server. For example, you want to copy this file to your R login. You'll be writing SCP space this file name space um, your PID at rlogin.cs.vt.edu. Then there's going to be a colon over here. This one is very important. And then you specify where in rlogin you want to put it. Okay. So for example, there is another one like SCP and okay, sorry, my bad. So that's something you want to be, you will be using to copy something from your local PC to the rlogin. And if you want to copy something from your rlogin, you will be writing like SCP and then specify whatever file you want to copy from your rlogin and then put a dot. This dot is very important. It basically means that wherever you are right now in your terminal, you want to put that file from rlogin to that particular location. Okay, so yeah, there is a command called which. It basically shows wherever that command is located. In this case, the star command is located as \user \bin \star. Okay, so every single command you use, for example tar, cd, or like mv, whatever, they are actually files. They are actually executable files. So every single command you have, they are some sort of program. Okay, so commands, programs, process, they are all interchangeable. By using the command which, you can actually see where every single command is actually stored at. Okay, so there's the concept of foreground and background. Every single command you have used so far was in your foreground, but like you can actually run commands in your background as well. So you can actually like communicate with your foreground commands directly, but if it's a background program, usually you won't be able to interrupt it. Okay, so if you want to write a program in your background, you use this ampersand. Like whenever you use this ampersand, it's that particular program is going to be ran in background, and you won't be able to communicate with it directly. And if you want to kill a process, you can use Control C, like press Control C, and that process is going to be killed. And killing basically means like stopping it. So Control C is equivalent to opening your task manager and trying to kill it. Okay. The other one is the kill command, and this one is very important. It's part of one of the Linux memes. Whenever someone says like kill -9, it basically means stop that, completely stop that. So how to use the kill -9? So you use like kill, then -9, and then you specify the PID of it. Okay. So remember we saw in the previous lecture there was the PS, and it says what PID is assigned to these processes. So I want to kill this one, right? So I just specify this number after kill -9. Okay. So I try to kill it, and it says that it killed this process. Okay. So that's it for the basic commands of Linux. You should try this by yourself as well. There can be so many combinations of them. So yeah, if you have question about any of them, feel free to write them in the piazza. Okay, I'll see you in the next video.